I'm going to really quickly go back to what we just did. So it's, what is today's date? November 15th. Doing kind of a review, but also a new lesson on rate of change. Slope is involved with that. We said the slope is this number, whatever's in front of the x, whatever's being multiplied by the x is the slope. The slope is also the same thing as the rate of change. So you're actually getting a quick review of what you just missed, Keyshawn. I'm repeating it for the recording. Said they're the same thing. We said when you have a table of values, or even if they were just ordered pairs, I guess, if the x values are going up by 1, which these are 1, 2, 3, 4, 5, 6, if there is a pattern of addition, that means it's linear, first of all. This is a linear function. We're adding 2 every time. And the pattern is the rate of change. So the rate of change for that table is 2. If you were not going up by 1 every time in the x values, here's the next step that you need to take in this lesson. You need to be able to figure it out, like figure the rate of change out from a table that isn't going up by 1 in the x values. Now, you could create a table. We've done this before. You could create the table and have it going up by 1 every time. Like fill in the missing values like we just did. Find whatever the pattern is to fill in the y values. And now you could just say, okay, that pattern is the rate of change. But there's another way to do it. If you're pretty good, you think, with memorizing formulas, like I said, you really only have to memorize it for 24 hours if you look at it the night before. Let's do it from this table first, and then we'll do it from a more. Let's say we only had those values, and we didn't know how to fill in a table, or we just didn't want to try to fill it. Here's your formula, so write this down. Might remember it before, you've done it. Probably wasn't a big, oh, that's fun. That's a formula. So that is the slope formula or the rate of change formula. Take notes. I'm going to memorize stuff. Writing it down. I did put the grades in for the last quiz. I wound up making it 2 separate grades. Because not many people did very well on the section about endpoint behavior and where the graph is increasing and decreasing. Didn't have very many good grades in that section, so that brought all the grades down. What I did is I split it into 2 grades, the symmetry and minimum maximum value was 1 grade, and then the other grades were the section where people didn't do very good. That way now when I do the retake, I can add just that section on, and you can automatically have a retake on that stuff. So there'll be like probably 3 or 4 retakes on this one quiz that you have this week. And I'm not going to put any new material on it. So this that we're learning now won't be on it. It'll be on next week's, because there's a lot more to this one. And you really need to practice this one than just today. All right, so I could fill in the table. I could make the table go up by 1 for the x values, and then whatever the pattern is in the outputs, that's the rate of change. But here's potentially an easier way for some of you. If I just take any 2 columns, does not matter which 2 columns. If it was a vertical table, it would be rows. But you basically need an x and a y that are paired together. X and a y, x and a y, x and a y. So I could use any of these. I could use that. I could use any 2 of these, I should say. And it doesn't matter which 2 of those 3 I choose. It'll work. I'm gonna use both combinations, so you'll see it comes out the same no matter what. You need to now label, again, I'm going to pick two. I guess I'll start with, and you say, this is my first, and I would do everything I'm doing right here. Again, if you get it perfect, fine, but ultimately people wind up making mistakes. They try to take shortcuts, so. So I'm going to call this my first point. I'm going to call this my second point. That's all. Oh, and we are on a very strict no phone thing. Take out headphones. That's all these little ones and twos are. It's just referring to one of the two ordered pairs. It's not math. There's nothing you're doing. It's not like a square, like squaring a number or any of that kind of stuff. We're just saying this y value right here, the y2, is going to come from my second point. This x value, x2, is going to come from my second point. And it's the x there, the y there comes, or these two. The ones come from the first point, x1, y1. That's all the little ones mean. So if you label it like this, and I'm even going to take another step, that might be enough, but I'm going to actually label each individual. Oh, where can I do that? Just, there we go. So if you do this, assuming you can memorize a formula for, like I said, 24 hours. There we go. So I'm going to pick these two. So this would be my I'm still using the same ones. I have 1 and 2. So that would be my X. Oh, wow, that was off. I wonder if it's when I zoom way in. Jacked up. Yeah. Oh, I didn't. All right, hopefully that works. I don't know. Okay. So that's my X1. This would be my Y1. Blue. This would be my X2. This would be my Y2. So all the 1 means is it comes from the first point. All the 2 means is it's coming from the second point. That's it. Now I just plug them in into the right spot in the formula. Hopefully we can fit all of it. Yeah. So I just say, okay, well, what's my Y2 value, Angela? Y2 value. Yeah. If you label it correctly, really shouldn't have too many issues after that. Ryzen, wake up. You'll still be able to do this. What's my Y1 value? -3. Charles, what's my X2 value? Sure, yep, 4. Oh, and always have the subtraction sign in there, by the way. Sometimes when people write the subtraction sign and they have a negative number, they'll want to take the negative sign out because they think the subtraction is taking place of that. It's not. This is part of the formula. This is the value that goes there, the number that goes there. Tanosh, what is my X1? X1, did you say 1 or negative something? The X1 value will be 1. don't know where you got -4 from. Do you see what I'm saying? Oh, I don't, that's not -1. Hold on just a second. Do you see where I got that from? Oh, so you did have a late bus? All right, I'll check on that. All right, so now that I've set up the equation, you just do the math. Be careful on it because 3 subtract -3 is 6, not 0. 4 subtract 1 is 3. So if you say 6 divided by 3, your answer, just like we had before, is 2. I don't care which way you do it on a quiz. If you want to, a little longer way, but if you want to create a table that goes up by 1 every time, if it doesn't already go up by 1 every time, then you can do that. If you just want to memorize formula and use formula, do that. Just be careful. Show your work though. If you're going to do this, show your work. Like, show me that you understand how to label them. Show me that you plug the numbers in. That way, if you happen to make a math error right at the end, and let's say you wrote 0 instead of 6 on top, you'd still get a C or maybe even a B on it. I don't really take that much off for math errors. Do take off for process errors. So if you haven't shown me the process, and I can't give you any points for that, you'd get a 0 as opposed to a B. Make sure you show me the labeling of the points. First point, second point, x1, y1, x2, y2. Show me the formula, plug it in, then do the math class. Might even be able to get a passing grade without getting a lot of it. I feel like you understood the process, you just made some rules. Any questions on that? So that will work for any table. It doesn't matter how complex the table is. If I give you a table, that one's actually not that complex. Tell me what the rate of change is on that table. Don't, like, not out loud. Go ahead and figure it out. Do it either way you want. Don't sit there and do nothing. You're pretty much telling you what exactly you're going to have on quiz. Exactly how your quiz will look, although it'll be next week. When this week we'll review after this. Not this one, but the next one. We'll get into next week, probably we'll get into why you use this. It is actually a very common, very important concept in business. Businesses work off what's called a linear sales model. What we're doing, linear functions. I used this when I had one of my jobs. I didn't even know it. After working? Oh, maybe 2, maybe 3. Wow, 4. Holy cow. You're not. This one's pretty. This one's pretty easy. You can actually do this the simpler version. I'll give you a hint. X's are all going up by 1, which means you can do this the easy way. Know this? All right, so if you're working on it the other way, or some of you are copying the table, which is a good idea, so you know where everything comes from. Again, if your X values are going up by one, X values are always on top. If the table is horizontal like this, the numbers on top are always the X's, the numbers on the bottom are the Y's. So if it's a vertical table, X's are on the left, Y's are on the right. If it's horizontal, X's are on top, Y's are on bottom. You may want to make a note of that. A lot of times on the district test, they don't just give you an X and a Y, they give you a label. And then you'd have to remember or understand that the top values are the X values. So if I'm going up by 1, I can just check and see if there's a pattern in the Y values. There's a pattern in those, and that's first of all, that would mean it's linear. So that's going to be a review we'll do in a second. But just to mention it now, I'm going up by 15, going up by 15, going up by 15. So yes, I went up by the same amount every single time. So there, it is linear. That's the first answer. It is a linear function, which means straight line. A lot of you missed that on it's kind of surprised that a lot of you missed that on the quiz. And the rate of change doesn't really say the question rate of change, but we'll just say it over here. Rate of change is that pattern of the Y's, the 15. You know what? We're not even going to do that one today. We actually already did it once, but we're going to do that next week since that's on next week's quiz. We need to do some review real quick for the current quiz. All right, so I'm going to show you what's on it first. We're going to create it. All right, so just copy down. Did not do as well on this as I thought we would. I thought this was going to be a section that was all 100s. It was definitely not all 100s. Not even close, actually. So that's on there. I also thought this section was going to be all 100s. It was definitely not all 100s either. And pretty surprised about that one. Linear or non-linear. Those are the two easy retakes. Next two are the two hard retakes, harder. So I want you to be able to tell me where is the graph, or it might say function, positive or negative, positive and negative if there's both. Do that. Not always both. There's not always a positive and negative. Well, yeah, there really is always positive and negative, unless it's a horizontal line. Where is it positive, negative? Actually, there's 3 more sections. Where is, it's all the same. If you don't know what this means, it means I'm just repeating that whatever's above. I'm repeating that. So where is the graph slash function? And then we did increasing, decreasing. Increasing, decreasing. And then again, I'm repeating all of that. Oh, actually, no, this one is different. And then we have to repeat, explain the endpoint behavior. Yeah, exactly. That was evident on the quiz. Explain the endpoint behavior. I'm going to go over all 5 of those, and you can practice. You'll have a good 45 minutes. I'm going to go over it fast. So if you're really not getting it, it's recorded. You can go back and watch the full recording. That. Do that after the day. You trust me, you need some tips. I'll tell you that right. You need these last, certainly you need these last 3, I believe. I don't remember if you got hundreds on the first 2 or not. Last 3, you can go ahead and focus on those. I'll look, but I'll just tell you right now, I know you need to practice these. All right, so when it comes to, and I'm going to go through these first two really fast. I was very surprised we didn't do better on those. When it comes to linear and non-linear, if you have a graph, hope I'm going the right way. Maybe not. All right, actually, we'll start here. If you have a graph, I'm sorry, if you have an equation, this is about evaluating, it's not on there, but just look at the equation part. So there's the equation part. Here's the equation part. A little bit. Here's the equation part. This is all you have. Don't worry about the y in front. Don't worry about the f of x. None of that. I mean, technically, you would have to worry about the y if it was potentially a y squared. They'll never have f of x. Well, I shouldn't say never, but mainly you're looking at the equation part where the x is. If there is no exponent, and this is not 100% of the time, it's for this class, it might even work next year too. I mean, there's a very specific situation when this is not true, and I don't even know if they were going to worry about it next year in algebra. If you look at the x, again, this would also apply to the y value, but I'm hoping they're not going to give you a y squared, but if they do, that would apply to the y also. If you look at the x, and it's just a normal x, there's no exponent on that. There's no 2, 3, 4, 5. Like, if you're not sure what I'm talking about, there's nothing like that on the x. There's nothing like this on the x. There's no exponents. No exponents higher than a 2 or higher. If you do not have exponents that are 2 or higher, not there. All you see is just the x. Doesn't matter what's in front of the x. Like, I think this threw you off that there was a fraction in front of one of the x's in one of the equations. All you're really looking for, at least for this class, is an exponent of 2 or higher. If you don't see that, it's linear. Pick linear. Odds are you're going to be right. So again, all of these are linear. There's nothing in here that's not linear. Literally says linear functions right there, so that's true. Now, if I did have a 2 or a 3 or anything higher than those, 2, 3, as soon as you have that exponent on the x, or again on the y, but I'm not even going to try to trip you up by putting anything on a y, it's going to be on the x. It was on the x on the quiz. And it's non-linear. All you got to remember, we didn't do as bad on that section as the other sections, but we didn't do great on it. There were not a lot of hundreds. Most people passed that section, but there were not a lot of 100s. So just remember, 2 or higher on the x, not linear. Nothing there, just an x, linear. All you gotta remember. I'd make a note of that because I guarantee you some of you are still gonna miss it. Don't make notes. Then look the notes over before you take the quiz. Any questions on that? So that's from an equation. I'll be honest, this is the one I was most, not this, the next thing. I was most surprised from a graph. I thought everybody was going to get the ones from a graph, right? A lot of people didn't get them. So here's a graph. So from a graph, if you have it, either a straight line or it's not. I thought for sure I was giving you questions on that. If it is a straight line, this is supposed to be straight, not curved. So think of that as a straight line. Straighter. If it is a straight line, it's linear. Again, write that. Straight line means literally the word linear means line. If it is curved in any way, so that, and again, there are other types of lines which are curved. We're not getting into them for this class. You'll get into them next year. For this class, just say it's it's still non-linear. It's still non-linear. That still works. Just saying linear or non-linear. So anything curved is nonlinear. Anything dead straight, again, keep in mind this one was supposed to be dead straight. It kind of came out a little curved. A little better. So linear, linear, non-linear. All there was to that. And I guarantee you a third of the people didn't get all three of those right. At least, maybe more. The last and the only, what I thought the only two difficult ones were, I gave you tables. We just went over that. If there's a pattern, so if you have one where the X's are not going up by 1, that's when you had to create this. I'm not going to go through and do that. If you want to go back and watch that video, it's posted. I don't remember the date that we did it, but you have got to have all the X's going up by 1. A lot of you didn't do that. A lot of you just took what was given, looking at it, and you said, oh yeah, there's no pattern in the Y values. Well, there wasn't a pattern, but you needed to check and change the table. And if you changed the table, then there was a pattern. Then there was another one that was like this, where the X's were going up by 1, but then there was a last column here, and it was something like that. So if you look, oh, hey, perfect. X's are all going up by 1. That's exactly what I want. Then my pattern is +3, +3, +3. And I think a lot of you stopped right there. And then the very last one wasn't +3 or wasn't plus whatever. It was a different number. It's non-linear. Only has to happen once. You need to go through the whole entire table and make sure that pattern exists or is continuous through the whole table. And there weren't even 5. There were only 4 you had to check, maybe even 3. You have a question, Charles? So that's, again, that's 2 of them that were just like that on the quiz. I think that's it for linear and non-linear. So let's talk about any questions on linear or non-linear. We did table, we did equation, we did graph. That was only 3 things that were on there. All right, let's go to discrete and continuous, or neither. Because again, I thought that was a super easy one as well. And apparently I was wrong. I'll just give you one. I'll give you one example of each. Perfect. So if I give you, blue one. All right. So if I give you points on a graph, that's discrete. A bunch of people missed that one. Don't know what you were doing in class. You missed that. You have a bar, or you need to ask questions if you're not getting it in class again. If I don't get questions, I assume you got it. We move on. That would have been an easy one for me to explain if for some reason you weren't getting it. You see dots on a graph. That's, and I mean like dots, like they got to look like dots, because there was one where I think some of you thought they were dots. They were not dots. They were little teeny tiny lines. That right there is dots. If you see, yeah, no, I'm sorry. Yeah. So if you then see that, there's no breaks in that. It's definitely not dots. So it is continuous. There's no breaks in that data. Like all the points are right next to each other, so close that it basically looked like it's solid. Technically, it's all individual dots, really, but there's no breaks in the data. That's continuous. So discrete, I guess I could write it down. Discrete, continuous, I'm not going to write that whole word out. Continuous means there's no breaks. Doesn't matter the shape. So this is not like linear, non-linear. That's the only thing I could think of that you got confused as you were thinking linear, non-linear. Continuous, discrete just means, is there a break in the data? If there's just dots, it's discrete. If there's no breaks, it's continuous. If it's neither of those, those are not dots. There are a few dots together in groups. Dots would look like this, literally circles. They're not circles, then they're not dots. That is neither. It's not discrete because it's not just individual dots. There's a few dots together. That's why they're a little stretched out. It's definitely not continuous because there are definitely breaks. All you needed to do on that one was neither. I guarantee you half the people didn't get all the points on that section. It should not have been difficult. Again, I can only give you the notes. I can't make you do anything. Nobody else is making you do it. I certainly can't. All right, so that's a repeat section. Pretty much just exactly like you see there. Any questions on that? All right, so we did linear, nonlinear, discrete. What was the other stuff I said was going on there? Linear, nonlinear. Both of those. All right, so now it gets a little trickier. So where is the graph positive and negative? And I get how these get a little trickier, mainly just how to write them. So what we said, and I don't remember how I did it in this class, but I'm going to change it to a second way that I taught it. If you have a graph, and I'm not going to make it even super complex, not going to be like super curvy or you got to really figure out different sections. There's just going to be two sections. I just want to know, where would the y values be positive? Where would the y values be negative? I'm just going to tell you for this. Go back and watch the full video if you want to try to understand it better. If the line, because remember, the line is the data. That black line is the line of data. All the grid lines mean nothing. If the line itself is above the x-axis, that's where it's positive. Because every y value, like if I pick any point on that graph and I write down the x and the y, what's the x and y value right here? T-shot, what's that x and y value? Where I just put that green dot. It's 2, 2, right? So if it's 2, 2, the y value is positive. Any point I pick on that graph, even if it's way down here, any point I pick in the highlighted section, the y value will be positive. It might be, what would we say that is? 1.01, comma, and then that might be 0.01 or something really small. It might be a really small number, but it's a positive number. 0 is not positive or negative. So if I pick 1, so that point right there would be 1, 0. So that is not positive or negative. So I wouldn't include that in either side. And then if I wanted the negative values would be every point below the x-axis. Any point that I pick on the graph down here, the y value is negative. So let's say I pick that one. Jocelyn, what's the x and y for that? Just approximately, you have to guess. So it's a little less than 1 for the x, because it would, this is 1, so we'd be a little left of that. So like, let's say I'm going to make this up. This is not accurate, but just to show you, let's say the x is 0.99, and then the y might be negative 0.01 instead of positive 0.01. Well, I don't know why I put that. The point is, any value below that dot, that green dot that's on 0, any value below that, the y is negative. So here's what you have to remember. We go straight to memorizing something. Above the x-axis, the line is positive. Below the are the y values or the graph. Sometimes I'll just say graph, not yet, but you see these review things. Below the x-axis, the graph is negative. The y values are what we mean when we say the graph is positive or negative. Function, all of that stuff is the same. The hardest part is going to be keeping this straight between the next two things we do. So if the graph is positive, it's wherever it's above. Now here's the last thing you gotta remember how to do. Oh, I'm gonna give credit. I did not really say this, but I'm gonna say it now. I'll have to tell the other classes. If you just do this, let's say you don't know how to take the next step and write it correctly, just at least do this. Circle it or something like that, because you probably won't have highlighter. And just do this. Positive. I'll give you some points for that. Negative. Circle the area that's positive. That, I don't know that just that won't get you a passing grade, but if you do enough on the other stuff, because I'm probably going to combine some things together, they weren't all separate grades, but that will get you, along with one more thing, that'll get you a passing grade. Now, if you want to do it correctly, where it's negative, I have to think, okay, what are the X values for this section of the graph, for this blue section that goes on forever? Keep that in mind. That goes on forever, never stops. So every X value starts right here, basically where X is 1, and it goes left. All the X values go into the left. So from here, going that way. All those X values are the X values when the Y values are negative. So the way I would write it is the graph is negative for X less than 1. So this means the graph is negative. So that's where the graph is negative. We just went over how to figure that out. The values of X are all less than 1. The number never changes, by the way. So that 1 is going to be in my next one also, because that's like the break-even point. That's why I flip from positive or negative. You'll notice there's no equal sign, because if I put an equal sign there, I'm including 0, and 0 is not negative. It's also not positive. So don't put an equal sign like greater than or equal to, less than or equal to. So the positive values are just the opposite. And will pretty much, if it's a straight line, they will always be opposite. Every X value going this way matches up with where the graph is positive, where it's in the yellow. So again, this X value here is 2. This X value here is 1.01. So all of those X values are where the graph is positive. So if you can at least circle and say, well, this is the positive section, this is the negative section, that'll get you a little bit. If you know that, though, if you can just remember, you just have to be able to write always in terms of X values, even when we do the next step. Any questions on that? A little behind schedule. I guess. Anybody writing? All right. So let's do. I got to do a curved graph for this next one. I guess I could make a curved graph on this. I like this graph. Oh, nope. For now. All right, so let's say I have this. Here. Oh, it's pretty close. So let's say I have this graph. The next thing you need to be able to tell me is where is the graph increasing or decreasing? Kind of similar to what we just did. Where is it positive versus negative? You're still going to do it in terms of X. X is greater than a number, X is less than a number. Here's where I said you're looking for the area. Oh, man, how did it just stop working right in the middle? Every class. All right, let's try that again. So that is going to be the, again, kind of the break-even point. What you're looking for here Where am I sliding down? E. Ah, again, this is me. All right, so that's me. If I'm right there, here's the tricky part of this one. You're always going left to right. If I'm going left to right and I'm following my graph, I would be sliding down up until I get to that point. It's horrible. Can't really do much else. I don't want to use the screen because that's not. If you are sliding down, the graph is decreasing. So wherever you're sliding down the graph, that is the decreasing section. I'm going to do the same thing I just told you I would do. I would just do on the other one. If you can just highlight the section and write decreasing. If you don't know how to write it, use it in terms of X. Do that. Kind of along with the other one. Kind of say, okay, they knew that. Now give them a passing grade. And then you do, so now from down here, if you are walking up, that's where it's increasing. So say this is where I'm increasing. And again, it goes on forever. That line goes on forever up. That line goes on forever up. Never stops. So you'd be sliding down forever on the left side. You'd be walking up forever on the right side. So that again is your only number you use. There's only one number. To the left of that, you're sliding down or you're decreasing. To the right of that, you're moving up, walking up, or you're increasing. So the way you write that is the same way you wrote it in the last problem. Still in terms of X. Hold on. X is less than, because I'm less than that number going that way, -2. X is greater than -2. This would be where I'm decreasing. A lot of people wrote that X is correct, but they got this backwards. Hold on. So that's how you would write that. So it's the same thing you just did for positive and negative. It's just you write increasing and decreasing. Okay, so thank you. So that's pretty similar to the last one. Like, you get one of those concepts, I would expect you to get both of those concepts. Any questions on that? So here's the next one that's going to confuse you because it's different than those two, but you're going to get it confused with those two. I would almost guarantee. Anybody still writing? So we also are doing, now it's actually working. So we're also doing endpoint behavior. So endpoint behavior has to do with endpoint behavior has to do with, let's try that again. Oh, my board is. This is only what's going on where the arrows were. A lot of us didn't get this. I think only 2 people got this right. All you're thinking, if I ask you about endpoint behavior, Charles, this is the one you bombed. Not good. You want to pay attention this time. You did the same thing last class. You fell asleep during the last. So, well, you didn't pay attention. So, all you want for the endpoint behavior, one endpoint is going to go like this. Endpoint is going left forever. Oh, thank you. All right, now I'm in good shape. So this endpoint, remember, even though it looks like it's kind of starting to turn down, it's going left forever. So as I'm going left, I want to know, what is this doing? Again, this is the tricky part, knowing how to write it. A lot of you can tell me what the arrow is doing. Well, it's going down. It's going down, it's decreasing. but you got to know how to write it. If I'm going left, so again, left arrow, you're going left. That's all you got to remember. Write that down if you want a cheat sheet version. If I'm looking at the left endpoint, I'm going left. Well, if I'm going left, or the X is getting smaller or larger, if I'm going left. David, or the X is getting smaller or larger? Getting smaller, right? So they're decreasing. So as X decreases, so you would probably put X, but even if you didn't, I'd still be fine with that. So as X decreases, because I'm going left, what's that arrow doing? What's the left arrow doing? Going up or down? Oh yes, going down. So that means the Y is also decreasing. You just look at one endpoint at a time. Doesn't matter at all what's going on in the middle of the graph. Nothing matters in the middle of the graph. If I'm looking at the right side, the right endpoint, then I'm going right. What are the X values doing as I go right? Manual. As I'm going right, what are the X values doing? Bigger? Are they increasing or decreasing? Increasing, right? As I go to the right, so right arrow, I'm going right. Well, as I'm going right, 1, 2, 3, 4, 5, hopefully you understand they're increasing. So as X increases, well, that's supposed to be increases, but my board. What's happening to that arrow? Is it going up or down? Then Y also increases. Now, I think a lot of you just took the example we did and you said the same exact thing in the example we did. This can change. It's not always going to be as X increases, Y increases, or as X decreases, Y decreases. It's not even close to going to always be the same. It can be the opposite of that. Sometimes Y is always increasing. Sometimes Y is always decreasing. You have to look as I'm going left, is that arrow, and if the arrow is going like this, if the arrow is going like that and it looks sideways, it's decreasing. It is, even though it's barely getting lower, it is getting lower as we go left. Same thing here. That's getting higher. It's barely getting higher. You never say right or left. It's always Y is either increasing or decreasing. So as I go right, so as my X values are going that way, Y is also increasing. As my X values are going or decreasing, my Y is also decreasing for that graph too. You want to go ahead, go. I still have another section you're going to miss, but back. Actually, do I have it? That might be the last one. Endpoint behavior. Oh, yeah, that's it actually. All right, so go ahead. Whichever one of those sections you don't get, you need to practice that. I'd start with these because they're the easiest. So if you don't get those, or if you just want to make sure you get them, because that should be an easy grade for everybody, I'm going to make that a separate grade. So I'm going to make this a separate grade. And I don't know if I'm going to combine this in some way yet or not, because it was separate on other quizzes. So I might still just keep it separate. So it might be 4 different grades. Well, that's what I'm saying, like 4 different reasons. Not new grades, but yeah. So you might be able to replace, your grade could go from a 0 to a 90. So it's a big opportunity. It'll probably be the only one you get this quarter that you do retakes. So that was just because I missed some days and we had to go through some of it really, really fast. Yeah, she's already been written. Oh, what is it? 15? you leave there, please come back here. Make sure you get there. All right, so I'll be honest, I don't remember exactly which pages matched up with this. But these, between all three of those, you could have all the different types of problems. I can help you find and try to figure out which ones are specifically the ones you want to work on. Actually, tell you what, I can. Oh, tell you what, I'll just look it up in the book. So the discrete, continuous, or neither is page 85. So 1 through 8 is discrete, continuous, or neither. So if you want to do that real fast, that won't take long. I mean, you should have already done it, but if you just want to look over it again, linear, nonlinear from a linear, nonlinear from an equation is page 86. From a table is page 87. I don't really have any linear, nonlinear graphs. Looks like there were none of those. You can try to do that, I guess, maybe from page 85. Hoping you understand that. That we're not doing that one. Sure about that? Remember you doing so well on the last quiz.
I got a 0 on one of it.
Oh, okay.
Which that might be about that, hundreds. Like this one. What are you doing?
Oh, but that was 2 sections, I think.
Yeah, it's the two, this one or this one.
Yeah, okay, I was gonna say,
So
yeah,
can I
it
just-
was all in
can I-
one grade.
Can I only do those?
Yeah,
that's fine. Okay.
Yeah,
That's pretty easy.
yeah, I'm not gonna make anybody do all
Can
the
you-
sections if they don't
Can
want
you
to.
reshow me the increasing? I understand that point. I just don't
Go
understand.
into your book and practice it. I'm not, I literally, that's where you had your head down. So I'm not going back and redoing it when you decided to have your head down. That's why you did, that's why you didn't do well on the other one, because you had your head down then too. So you think you would learn to do that. See if this is even. No, that's not even those pages. So 97, you don't need to do. That's not on here. So don't worry about 97. That was intercepts. That's not on this graph.
Wait, so what page?
So 85, 86, 87 are all on this one. Especially 85. I don't remember how you did, but I'll look it up real quick. If you need me to look up what you need to do well on, you can come up here one at a time though, so nobody else right now. Oh, let me. I totally.